In a triangle, angles and their opposite sides are closely related. In this video, let's learn about the sine law for acute triangles and how we can use it to help us solve problems. The sine law works for all triangles. However, we're going to start off the lesson by teaching the core concept of the sine law as it pertains to acute triangles. Note that all angles within an acute triangle are less than 90 degrees. Okay, so here's a triangle. Now it's important to note that the angles and the opposite sides are rather closely related. If you think about it, widening this angle over here would result in the corresponding opposite side to become longer. And if this angle was made smaller, then this side would become shorter. In light of this, I present to you the sine law. What this is saying is that the ratios between all angles and their opposite side lengths are directly proportional to each other. We can also rewrite the exact same sine law in this way if we wanted to. Good, so let's try an example now to get a better hang of what we just learned. So, how would we go about a question like this? Well, let's start off by bringing up the sine law in both the forms that we looked at, since either one will help us find our answer. So let's just choose whichever one we want to use. And notice that we have two pairs of information to work with, so we can plug them into this segment of the equation. What we get when we plug the values in is 6 over sine of 68 equals k over sine of 54. Great! All we have to do now is multiply both sides by sine of 54 to get the following. Let's just rearrange both sides, then punch this into our calculators, and we get k equals roughly 5.24 units. It's as easy as that. Remember, since we do a over sine a equals b over sine b, all we need to have are any of the three pieces of information at a time in order to compute a numerical answer for the variable that we're interested in. We could have two angles with one side length provided to us, and we would be able to find the side length opposite to this angle. Or we could have an angle with two side lengths, and we would be able to get the angle opposite to this side. The sine law, however, isn't applicable in a situation where we have two side lengths and an angle in between. This is because we need to be provided with at least one pair of opposites and another value in order to use the sine law. Awesome, so let's try another example using the sine law. In this case, we're being asked to find the value of angle x instead of a side length. Alright, so this time we'll use this version of the sine law, just to demonstrate that the two are the exact same and that there is no difference. So all we have to do now is plug the respective values into the formula to get sine of 78 over 6 equals sine of x over 4. Let's simplify this by multiplying both sides by 4 and rearranging it. Now, how do we wrap this up? Well, remember that we can take the inverse sine of all of this right here. If we punch all of that into the calculator, making sure that we've included all necessary brackets, we'd get roughly 40.7 degrees. So there's our value for x. Alright, now let's say the question added another aspect to it. What if the question wanted us to find the value of this last angle, labeled, let's say, z? How would we get that? Well, if you remember, all the angles in a triangle always add up to equal 180 degrees. And since we now have two angles within this triangle, all we'd have to do is 180 minus 40.7 minus 78 to get 61.3 degrees as angle Z. And remember, since we rounded 40.7 earlier, this angle would also be an approximation as well. Great. Okay, and let's say the question decided to ask us one last thing, which was to find the length of this last side of the triangle, labeling it C. Should we do sine of 78 over 6 equals sine of 61.3 over C? Or should we do sine of 40.7 over 4 equals sine of 61.3 over C? Well, the answer to this is that you can use either of them. Just pick one and solve for it. But you'll also notice that since we rounded this angle, and since we also rounded this angle, the answers will be slightly inaccurate and different from each other. The amount of inaccuracy you'll find will depend on how much you've rounded these angles. But again, if they were never rounded off to begin with, you can expect to see identical answers using either one of them. So that's it for this one, guys, and we hope you have a good one.